بسم الله الرحمن الرحيم رب زدني علما.
So now the next thing we'll try to understand about the map servers. So there are multiple different components we'll see, like we have something called mapping servers or map resolvers, and then we have an alt router, which we'll be covering a little bit later. So probably here I'm just going to discuss only about the map server. But again, these three different components are linked with each other. So the map server is the one which is going to maintain the database. And that database is going to, what is the database is nothing but the mapping of your endpoint identifier with the routing locators. Because the entire process of routing or the packet being sent with the help of Lisp, and it's going to identify where exactly that particular endpoint is based on the routing locator. So the routing locator is going to decide or tell the or tell which direction or which place that endpoint is destined for. So in our case, we will be discussing about the mapping server or the map server, which is responsible for maintaining the centralized database relating to the EID, that is endpoint identifier, and the routing locator mapping entries. And with the help of this mapping information, all your ETRs, so your egress tunnel routers, probably this mapping information is actually learned from these ETRs. And then it's going to be published into the distributed mapping database. So we'll see that, but first we'll try to understand how exactly this information is being learned. So let's see the learning process first. So the learning is from the ETR, egress tunnel router. Now these are the tunnel routers which are located on the network edge, like here, and these ETRs are responsible for receiving the packets from the Lisp side. So you have the Lisp side here. Now this particular Lisp side is going to receive the Lisp packet from the endpoint, and that reaches the endpoint, which is again responsible for decapsulating those packets. So we already discussed about the roles of ETR and the ITR in the previous sections. Like I said, this ETR is going to play an important role in contributing the mapping of your information. So whatever the mapping database which is being built, the ETR is going to help out. So whenever this ETR receives a packet, it is going to carry that information about the source of the endpoint identifier. So because this is the endpoint, now this endpoint is mapped with this routing locator here. Now this mapping information is being learned or updated to the mapping server here. So now let's try to understand this information here. So to understand the process here, the functioning of the ITR and the ETR here, let's try to understand with a simple topology. Let's say we have a host here, 100.1.1.1, and we have a host on 200.1.1.2. That's an endpoint, let's say. So an endpoint 200.1.1.2 here. Now, we already know that this particular host is going to send out a request to the gateway, the router, and then there will be some kind of DNS lookup. If you're trying to resolve name to IP address, and then the packet is sent to the ITR here. So once the ITR receives the packet, now the ITR is responsible for sending out this packet and reaches the ETR or the remote locator, whatever, and it's going to encapsulate the packet. So that is typically the Lisp encapsulation, what happens. So the encapsulation is done by the ITR here, and then there will be an ETR which is responsible for decapsulating the packets at the other end. So now in between the source and the destination, or the ITR to ETR, there is something called the database, because how the ITR is going to learn that it has to send this packet to the ETR. So there must be some kind of information. So the mapping server is the one which is going to maintain the information. So which means now here, this 200.1.1.2 is the actual endpoint address which is supposed to reach. Now this endpoint is actually updating the local ETR, and this is the routing locator, and this mapping information, which means now there is a mapping information is maintained by this particular mapping server saying that this is the endpoint, and to reach out this endpoint, this is the IP. Let's say some IP 5111. I'm just assuming that is an IP address. Okay, so at the end, the mapping server is the one who is responsible for maintaining the database, and ITR and ETR are responsible for encapsulation and the decapsulation, as we already discussed that information earlier. So what are the different rules? Basically, the lists, the mapping server is responsible for distribution of the database. Again, distribution is also important because you just not use one mapping server. So typically, you may have a multiple mapping servers which will be responsible for maintaining the database. And as you cannot just go with a single mapping server, so that's going to be a kind of a single point of failure. So you will be distributing this mapping server information. So probably you're going to publish this mapping information to a kind of a distributed mapping database, because the mapping server is the central authority for maintaining all the mapping information relating to endpoint and your routing locators, which is basically the information to forward or way to forward exactly based on the endpoint identifier. So this database publication has to happen. So this mapping server is again going to publish all the mapping entries into the distributed mapping database. Again, this database is accessible to various components within the Lisp network. And again, this database is going to act as a reference point for all the routing decisions. And again, as I said, this distribution is mainly to provide high availability, because you don't want a single point of failure. So this will ensure that your database is highly available and it is accessible across the network. Across the network, you have access to that. So during this process, again, there are multiple other things happens here, like the Lisp site registration. So this distribution is done with the help of other things, like there is also something called Lisp site registration also happens, because whenever a specific site, let's say there is a new site, is going to be added here. Now this is my new site. And whenever this new site decides to become a part of the Lisp network, then it has to make sure that it is going to initiate the registration process by contacting the mapping server, which means, let's say there is a new router I'm going to add. Let's say this is a new router and that has to be a part of the network, ingress ITR. And this is my branch office. Now this branch office has to initiate a registration request to the mapping server. So we call it as a registration process by contacting the mapping server. Now, once it sends the registration process, the next thing is it also has to do authentication and the policy. So which means now this particular Lisp site is trying to register with a mapping map server. And there must be, in order to confirm, there must be some kind of authentication process involved, because the branch office has to authenticate itself before it becomes a part of the Lisp network. So which means this particular router is going to provide, or ITR is going to provide some kind of credentials according to the policies configured by the map server. And then the authentication will ensure that only the authorized Lisp sites can register, because there is a possibility that any unauthorized router, I don't want that to be a part of the network. So that is kind of a security reason. Now, once the authentication process is done, there will be some kind of route injection. Now, route injection, now this particular branch office is now part of the Lisp network. So which means now this map server now registers this particular branch office as a Lisp particular site, and then it will inject relevant mapping. So whatever the networks or the endpoints connected here, so probably that information it has to update inside the mapping database. So that is typically the route injection, we call it as. Now later on, the same thing, again, there will be a map request. Like let's say if there is another site wants to request or wants to get some mapping information. Let's say we got a new host added here to the list, and this particular host here trying to communicate with this particular host somewhere here. So it has to initiate a map request. So whenever they wants to communicate, they need to initiate a map request. And this map request is being initiated in order to maintain the mapping information for the endpoint. And of course, finally, there is also encapsulation happens. So again, the map server encapsulates the map request. So whatever the map request which are being sent or requested, they will be encapsulated. That is what encapsulation to ETRs with the required information and then forward it to the ETRs. And then later on, it will decapsulate the ETR will decapsulate and send it to the necessary device or response to the necessary request onto the LAN. So if you observe here, in short, we can say like the map server is basically a database. So the map server, you can say, basically it's a database which maintains the information about the endpoint and the routing locator information. And while it is doing that, not only just it maintains that, it also responsible for other things like ensures that any new sites getting added that has to register, and then the authentication also it will do, and then add the routes, the endpoint identifier routes, and then even if there is any new map request, as well as the encapsulation, because the encapsulation to the end ETRs also is done between them. So basically, it is going to facilitate the communication between the sites with the information, and that information is nothing but a database. And this database can also be distributed to multiple devices in order to maintain that it is highly available and accessible across the Lisp network.